permutations and you didn't even know it. So when you do words, order matters, correct? If not, loop and pool are the same thing. Or lopo or polo are all the same. They're not the same, correct? So the order of which letters happen matters, changes your words, correct? So permutations, order matters. Combinations, order doesn't matter. So words are permutations. So here it says, and so are digits. Like when we did the 4-digit number, if order didn't matter, then the number 4001 is the same thousand as 1004, which it's not. Okay? So numbers, codes, words, all are permutations where order matters. So we're going to look at these ones, which are a little more advanced than the ones we did 2 days ago. So it says, find the number of permutations of letters in the word kitchen. So kitchen has how many letters? 7. Now, are there any doubling or tripling letters? No, there's 1 K, 1 I, 1 T, 1 C, 1 H, 1 E, 1 N. There are 7 letters. Can I repeat them? No, I have Scrabble tiles, right? Or I have pieces of paper like I had the other day where you have 1 K, 1 I, 1 T, 1 C, 1 H, 1 E, 1 N, right? So here it says the letters K, C, and N must be together, but not necessarily in that order. So I'm still going to do my blanks because I can put 1 letter here and 1 letter here, 2, 3, 4, 5, 6, 7. Now, whenever it says the KCN must be together, I always put them at the beginning and then move them after. So I hook them together at the beginning. So I do this. I go, I'm going to put them together right here. So I hook them together. That's where I'm going to locate the KCN. I'm going to have to move it because it can be together in other places, but I'm going to start with it there. Okay? Now, if it said KCN in that order, this would have to be a K, a C, and an N, and then it would be 1, 1, 1. We agree? But it doesn't say KCN in that order. It says KCN not necessarily in that order. So for the first blank, what options do I have? 3. I have K, C, or N. We agree? Now, remember with words, you cannot repeat unless there actually is a repetition of that letter, correct? So whenever we do words, we box and hold. So I'm going to hold the N. Then I could have KC, which is 2. And then I could have K, which is 1. Now, how many letters have I used up? 3. How many letters do I have left? 4. So in this blank, I actually have, bless you, all the rest left. So I have I, T, H, E, left. So I have 4. And then I'm going to hold one of those. Then I'm going to have how many? 3, 2, 1. We agree? Okay, put your pencils down for a second. You're not doing this, I'm just showing it to you. So currently we have this. We agree? I'm not going to show all these cases, so I want you to put your pencil down because it's excessive, but I want to show you how this works. So we can have the KCN at the front. We agree? Or it just says they have to be together. If it said together at the front, we'd be done. We would give this answer. But it says together. So they could be together in front of this letter, correct? Or I could move these 3 in between these 2 letters and it would make a totally different word, wouldn't it? If I moved these 3 between this and this, it would make a totally different word. Yes? So I'm going to show that example. Don't do this. I'm just proving it to you. And then I would still have 3, 2, 1. So I could have this case, or I could now move them between these 2 letters and it would make a totally different word, wouldn't it? Or I could move it now between these 2 words. I'm being excessive with my dots, but that's good. 4, 3, 2. 3, 2, 1, 1. Or I could take these letters and completely put it at the very back. Yeah? Now, if I multiply these, am I going to get different answers for each one? No. It's technically 3 factorial, 4 factorial, is it not? 3, 2, 1, 4, 3, 2, 1. So this is technically 3 factorial, 4 factorial. Well, so is this. 4, 3, 2, 1, 3, 2, 1. 3 factorial, 4 factorial. This would be 4 factorial, 3 factorial. 4 factorial, 3 factorial. 4 factorial, 3 factorial. That's all they all are, correct? What is 4 factorial times 3 factorial? It's 144. We agree? How many cases do we have here? 1, 2, 3, 4, 5. So could we just go 144 times 5? Yeah. I will never list all these cases. I'm going to show you. We can go back and pick up your pencil. The way I do this always is I'll move it with arrows because I can show it that way, but also there's a faster way. But I'm going to show this way too. So I can have them here, which is one case. We agree? The way they're sitting. Yes? Or I could move these 3 here, which is 2 ways. Or I can move them here, which is 3. Or here, which is 4. Or I can move them directly to the back, which is 5 ways. Correct? So that's multiplying by 5. Another way, easier way to remember it, is that you always end up multiplying by 1 more than this number. So if this number after the hooked together numbers is 4, then there will be 5 cases. If this number after the hooked together numbers is 9, then there will be 10 cases. Because it's always 1 more than this number, because there's going to be 1 sitting in front of that number, 2, 3, 4, 5. Right? So you always have to multiply by 5. So this is actually 3 factorial. And then what's this? 5, 4, 3, 2, 1, blast off. Correct? So this 5, 4, 3, 2, 1, even though it's out of order, is the same as 5 factorial. And they could just give that as an answer in multiple choice. Remember, you can always work those down to decimals, unless it's a numeric response. And this would be 720. How do I know that? Because 3 factorial is 6. And then it'd be 6 times 5 factorial, which is actually 6. Okay. B is a tricky one. It's the one that I always star that everyone forgets how to do. It's when things can't be together. So here it says the number of permutations. So they won't say permutations, they'll say the number of arrangements. And arrangements is a fancy way of saying order matters. If you're arranging something, you're giving it an order. If you ever see arrangements, it's a permutation. Of the letters in the word kitchen, if the vowels must not be together. So the vowels can't be together. Everyone putting down pencils. Okay. If I asked you how many people are not in this class that are in this school, would the fastest way be to walk out of this room immediately, go walk to Mr. Clay's room, count the kids there, say, everyone stay still, and then go to Mr. Crawford's room, count the ones in his room. Then walk down the stairs, go to Mr. Dickey's room, count those ones, hit up the bathroom in the middle, be like, anyone in there? Count those ones. And then, like, someone late walks in the room, you have to make them halt and like stay in with Nancy. Be like, hey, did you count them all? Would that be the fastest way to do it? No, you're probably missing 1, 2, or 10 people, correct? You're also missing people sitting at home, unless you're going to go drive to their houses and then count them as well. Okay? Super awkward. So, that is really strange to do it that way, correct? Whenever I give this question, the vowels must not be together, people try and make cases where the vowels aren't together. So I do a case here where I put the vowels not together than here, and the vowels not together than here. I try and make up 77 cases. Do you assume that would be the fastest way? No, that's equivalently as hard as you trying to count the kids in all the classes and the ones at home. Okay? What would be the fastest way to count how many people are in this school but not in this class? Yeah, go to Miss Atkinson. Hey, Miss Atkinson, how many people are in this school? And she'd say, 800, I don't know how many there are. And then you'd be like, hey, Mrs. Lepp, how many people are in this class? And I'd say, oh, guys, there's 27. And then what would you do with the 2 numbers? Subtract them. Is that not the fastest way? So when I say vowels not together, and you start doing 77 cases, this is not the fastest way. But what we could do is we could take all the different ways I could rearrange kitchen. No restrictions, right? Like every single different word I could get out of kitchen. Correct? That's like the total number of kids in this school. So we do total words from kitchen. Well, total words from kitchen means there's absolutely no restrictions. So how would I figure out the total number of different words I can make from kitchen? Just do what we did before. 7 blanks. The first blank would have a 7, then a 6, 5, 4, 3, 2, 1, right? So it's actually just 7 factorial. Now we're actually never finding out the ways I can not put the vowels together. We're actually doing total number of words. So 7 factorial, I believe, is 5,040. So there are 5,040 different words I can make out of the word kitchen. And by words, I mean words loosely. Not like you go look it up in the Scrabble book and see if it actually is a legit word. I don't really care. Just that words that look different, right? There are 5,040 different words I can make with kitchen, maximum. Just like there's 800 and blah, blah, blah kids in this school, right? Then I subtract the kids off in this class, 27, and I get equals the people not in this class, correct? So what do I have to subtract here? I take total words and I subtract what? The way the vowels can be together. So if I take the total and I subtract all the words where the vowels are together, what's left over? The vowels that aren't together. That's it. It's way easier to find vowels together because I can do it exactly the same way I kept KCN together. Exact same way, right? So if I take total number of words in kitchen, which is 5,040, and now I subtract off vowels together, what's left over will be the vowels not together, please. Kitchen has how many vowels? It's a subtraction sign, not a blank. It has an I, an E. Does it have any other vowels? No. So how many am I hooking together at the front? 2, right? So I'm going to hook 2 together at the front. This is my I or my E, correct? So for the first one, I would have I, E as an option, so 2. And then my second one, I could have E as an option, which is 1, because I have to hold them, correct? How many letters do I have left for the rest of the blanks? 5. So I have 5 for here, then I hold 1, 4, 3, 2, 1, and then that's all the vowels together? That's the vowels together at the front. What do I have to remember to do? Yeah, it times by all those cases, correct? So it's always 1 more than the number after they're hooked together. So what are we going to actually multiply it by? 6. We're going to multiply it by 6 because it's always 1 more than this number, right? So this is 1 case, 2, 3. I'm going to do it in different color. 1 case, 2, 3, 4, 5, 6. It'll always be 1 more than this because there's 1 in front of it and 1 at the very back of the 5, right? So we multiply it by 6. So it's actually 2 factorial times 6 factorial. You don't have to write 2 factorial because it is just 2, but I'm proving the point. So that's going to be 1440. So we're going 5,040, which is all the words in kitchen I can make. Then I'm subtracting, bless you, I'm subtracting off all the vowels together options, correct? And then what's left over are the vowels not together. So what's 5,040 minus 1440? Does that make sense? If you liken it to finding all the people in this school that are not in this class, it makes it a little bit more sense. Okay, I want you guys to try example 2. You do this one. So we have the word oranges, an O, an R, an A, an N, a G, an E, an S. No double ups, no triple ups, right? And oranges has 7 letters. Double count your letters every single time. There's nothing sadder than someone who puts 8 or 6 and just miscounts the letters. It gets the question wrong. We're so sad. So there are no further restrictions. It's going to be 7 factorial, which is 5,040, because you literally, that's just all the amount of different words you can get from a 7-letter word, right? We just said kitchen. It was the same thing. 7 for the first blank, 6, 5, 4, 3, 2, 1. Then the next one. The first letter must be an N. Can you please go back and double check that you're putting dots for multiplication and that you don't just have really large numbers sitting on your page? If you're missing dots, go back, put them in, okay? So the first letter must be an N. We have one option, we hold that there. Then how many do I have for this one? 6, then 5, 4, 3, 2, 1, which is 6 factorial, which is 720. Then the vowels must be together in the order O, A, E. So the vowels must be together, and they have to be in this order. So no 3, 2, 1s at the front. So I'm going to hook these together. They have to be in the order O, A, E. So it's 1, 1, 1. Right? Not 3, 2, 1. And then we have 4 left. Then 3, 2, 1. If it said together at the front, we would be done. But it just says together. We agree? So how many ways can we move it? 5. It's always one more than the number after they're hooked together, right? So if this is a 4, we multiply by 5. Because we can get 1 here, and then 3 other spots in between. So we multiply by 5. I always show it like this. I don't know why. It's an addiction. I put a multiplication symbol. Proves that we're just making more cases is why. Okay? So 1 times 1 times 1 does nothing. 5, 4, 3, 2, 1. Blast off gives me 5 factorial. So I can be lazy and not type in all those numbers. And I get 120. Okay, we're going to go to 4. 4 says, in how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? So we have 7 blanks and we're arranging them. So it's a permutation. This here screams perm. Oh my gosh, I love my board so much. No, I don't. Not at all. Also, you're putting people in seats, so you're arranging them in a specific order. Okay? So we have 7. 1, first seat, second seat, third, fourth, fifth, sixth, seventh. How can I do it so that no girls and boys sit together? Yeah. Nope, even faster. Yeah.
Go boy, girl, boy, girl.
Boy, girl, boy, girl, boy, girl. Start with the boy. Then you'll never double up, right? Because there's 4 and 3. There's one more boy than girl. So we can go boy, 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 boy. So is it 4, 4, 4, 4? No, we go down by a number, correct? Because we have 4 boys here, but then what do? Say sit down. That's what I do when I sit down. Then what do I have for this one? 3, sit down. 2, sit down. 1. Then the girls fall in between. And I have 3 girls, tell it sit down, 2, 1. Now what does the purple make? 4 factorial, 4, 3, 2, 1, right? What does the green make? 3 factorial. So I could actually write 4 factorial times 3 factorial, which is 144. Now what if I change it? You do this question. You can do it at the bottom. There's space. I want you to do, what if it's 4 boys and 4 girls? And no 2 boys and girls can sit together. How many of you started with a boy? How many of you started with a girl? How many did one case? Could you start with a boy?
Yeah.
Could you start with a girl? Would it make it look totally different if you looked at the picture? If I gave you a picture and you had a boy, girl, boy, girl, boy, girl, and then I gave you a picture and it was girl, boy, girl, boy, girl, boy, could you tell the difference? Yeah, so those are different pictures, right? So when it's an even amount, you have to watch out because you're going to get two cases. You could have a case where you start with a boy, which is 4, 3, 2, 1, and then 4, 3, 2, 1, which girls in between. Or, which means we add, it's supposed to be two separate lines. Thanks, board. Oh my gosh. You can start with girls and it would look totally different. So you could technically show two cases, or what could you do? Multiply by 2. Yeah. So we could just go 4 factorial, which is this one, and then times it by 2. Look, we can actually do math with our calculators. It's a crazy thing. We like to push double digit. Is it wrong? Should do it slowly. 6 is the 576, right?
Yeah.
So it's by multiplying by 2 that I went downhill. Cool. I don't even know where to go. Let's try again. Not go so fast, Lepp. 2, 16, or 6 times 2 is 12. 7 times 2 is 14 plus 1 is 15. Oh, I didn't carry my 1. Shameful. And this is why we should still have to do real multiplication. We like push it so hard in like elementary school and then things go awry. Yeah.
Would that would it technically be like 4 factorial, like the power of 4? For the total answer, because you're just multiplying 4 factorial 4 times.
Well, no, you're going 4 factorial. You could technically, I guess you could get away with it, but technically what we're doing is we're going 4, 3, 2, 1, right? Which is 4 factorial, and then 4, 3, 2, 1, which we're multiplying by 4 factorial. But then here we're multiplying it and adding it. So we're taking 4 factorial and 4 factorial, multiplying those, then adding 4 factorial, 4 factorial.
It's just like showing like that, like where you were.
Yeah, they won't show 6 factorial of 4. Yeah, but in this instance, only because they're even numbers. Like if it was like something different, yeah.
This might already been covered, but why is it like why are
Starting
there
with
8?
but one argument, but it's gonna go badly. I see
Why?
this going badly.
Why are there 8 spaces to begin with? Don't we have 4 male rows and 3 female rows?
Oh, friend. So true on the question above, but we're not doing the question above. So I said, let's do a separate question below at the
Yeah,
bottom.
that's why.
We're going to make it 4 boys and 4 girls. Yeah, so true, fact. If we were doing the next question, yes, exactly right. 4 and 3. Mm-hmm. Yeah. Yeah. That's why it didn't go well for you.
Yes.
Yeah. There's a little break in there. Didn't go well for me multiplying by 2, which I could have just done in my head, but I wanted to prove how to multiply by 2 and then I screwed it up. So, we all have things. We all have things. Look how beautiful that blue looks when you put it over the green. It's the little things like, don't give me that look, James. It looks beautiful. He's like, you're nuts. No, James, I'm not. Carrying on. We aren't actually doing that question, which is slightly funny that you did it, Ty. Carrying on. To the next page. Whoa, why did I... How did it skip ahead to binomial theorem? This board has more problems than you could shake a stick at. I don't even know what's going on. Let's see if the other one does it. I'll reprint for period 3. That is a quiz. We're back. All right. So for all examples we've had, they've had different letters. But as soon as we have words with letters that repeat, we have to account for them by dividing by the total number of arrangements by the number of letters. For example, Peter. I always do this. I write it like this. Nope. I write it with a marker. One second. Nope. Don't want that. Okay. Cool socks. Peter. Now, you're like, that doesn't spell Peter Lepp. That's weird. That's okay. It's weird for a reason. If you stack the letters, you will see, hopefully, that there are doubling letters. Also, hopefully, stacking the letters will remind you that, hey, I got to do something about that. Because if I take Peter and I swap the E's in Peter and put them in the same spots, I still have Peter. Do I not? I didn't change the word at all, correct? So it would be really hard if you had to always be like, okay, if I swap these E's, it's different than if I swap these E's, that stays the same. So I got to take that case off. Then I start with an E and I end in an E. But if I swap those, I have to take that case off. Like, that would be awful to have to figure it out that way, right? So all you do is you treat Peter like they're all different letters, and then you just divide by the factorial of the doubling or tripling letters, and it gets rid of all the cases where they're actually the same. It gets rid of all the issues. It's quite fast. So if I take Peter, and I'm just trying to figure out how many ways I can rearrange Peter. Peter is 5 blanks, right? And I just pretend that they're all different. Okay, so I have how many options for the first one? 5. Then I leave a letter. 4, leave a letter. 3, leave a letter. 2, leave a letter. 1, and I would get 120 ways. 120 different words from Peter. But that's actually not true, right? There's going to be ones where I'm going to swap the E's that they're going to look the exact same. Correct? So all you do is you divide by the factorial of the doubles or triples. So in this case, there's 2 E's, so I just divide by 2 factorial, which gives me 60. And there's actually only 60 different words in Peter that look different, because that takes out all the cases where the E's are the same. So here it says a set of n objects with A of one kind that are identical, B of a second kind that are identical, and C of a third kind that are identical, and so on, can be arranged by putting n factorial over A factorial, B factorial, C factorial. So here it says, how many different 10-letter arrangements can you use in the letters of the word basketball? I'm going to look. I wrote basketball. I wrote basketball. Are these 2 words different? No, I'm a magic. I switched the 2 L's. Can you tell? Look how amazing I am. You cannot tell, correct? It's the exact same. I backspaced one out and put the other one in. Don't kid yourself. I did. I actually, when I did these notes, I changed the L's. You just can't tell because they're not different. That is the same word, right? So what do we need to do? We need to write out the word basketball. B-A-S-K-E-T-B-A-L-L. So now I see that there are actually 2 B's, 2 A's, and 2 L's. Do we agree? And I do this so we don't miss any, because sometimes you'll miss like that there are actually 2 B's if you don't rewrite it. Okay? So if I just want to say how many different ways can I arrange basketball, what would go on the top? 10 factorial. Because we would technically have 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1 blast off. Correct? Because I treat the top like all the letters are different, even though I know there are 2 B's, 2 A's, 2 L's. Okay? On the bottom, I'm going to go 2 factorial for the B's, 2 factorial for the A's, 2 factorial for the L's. Now, if you have the fancy new calculators, can you follow along? That means not the TI-83s, most of the TI-84s. Okay? So what you're going to do is you're going to go alpha y equals, enter. My calculator's not up anymore. Alpha y equals, enter. And what shows up? A fraction. Does it not? Just type it in. If you have the TI-83s, you have the TI-83s, you have to make sure to put this in brackets. If not, what your calculator is going to do is it's going to go 10 factorial divided by 2 factorial, take that answer, times it by 2 factorial, take that answer, times it by 2. But what we actually wanted to do is 10 factorial divided by 2 factorial, 2 factorial. So, if you have the newer calculators, you can go alpha y equals, enter. I don't think it's following with me. What does it do? I'll just turn the... It's frozen. Why is it... Anyways, imagine with my finger that I'm doing this, because it's not doing it. Alpha y equals, enter, and a fraction pops up. Okay? If you have the ones that are chargeable, like the ones that you recharge, you have one. If you go alpha link, for most of you, that'll pop a fraction. Alpha link. The rechargeable ones. If you have the TI-83s, which is totally fine, it's better than mine. Mine isn't frozen, not even doing anything, so that's fine. Oh no, did it freeze my whole board? Whoa, that was making me panic a tiny bit. You have to make sure that you put it in brackets. So what answer do we get? Okay. Now, we're doing a moment. We're taking a moment here because we're going to be doing some big numbers. And then no one answers me because they're scared of saying them. They're like, I'm not sure how to say it, so I'm just not going to answer you. Well, we're going to make a moment so that you say the answers. I do this every single time at this very moment in life, every class. Ready? Okay. If you can say 3-digit numbers, you can say this number. So, what we do is we say the number. What is this number? It's in the what spot? Billions. So we have 6 billion. What's this number? It's in the what? What's this number? It's in the, and then this is just the, so you have 6,789,543,986. Now when I ask you to say a number, you're going to be able to say it, and not be like, no, that I can't. It's stressing me out. I even take this 6,789,543,986. I will take that as an answer. I will. I will take any answer as long as it comes out of your mouth with numbers. I would appreciate it properly, but I will take it in 1-digit intervals for the whole thing. I have no shame, and this is a safe zone. So I need you guys to say the numbers. This is a safe space, except for if you've been papers. Then it is not a safe space. Just kidding. All right. So, it's totally a safe space. I will not judge you. As long as you don't judge me when I can't multiply by 2. All right. So, if we take aardvark and the A's have to be together, we have A, R, D, V, A, R, K. We need the A's to be together. Well, the very first thing I do the moment I do this is I'll go 3 factorial, 2 factorial on the bottom. I do that before I even answer the question, because you're going to have to do that. Aardvark has 5, 6, 7, 8 letters. And I have to keep the A's together. So I go to the front, and I hold the A's together. Now the key thing to this is you treat them like they're different, correct? So how many A's do I have for the first blank? 3. Then I hold an A there. Then I have 1. Now people will say, well, if you have A, they're all the same. Remember, the factorials on the bottom, get rid of those cases. You treat the top like they're all different. Then how many letters do we have left? 5, 4, 3, 2, 1, and we're done? No, we have to multiply by 6, because it says together. It doesn't say together at the front. So remember, there are 6 ways I can move that around. So this should be 360, because you're going to end with 3 factorial, 6 factorial, over 3 factorial, 2 factorial, those cancel, 720 divided by 2 is 360. Then we're going to scroll ahead so I can show you what you have to do for some work here. So if you look here, this is your assignment page in your textbook. I'm going to downsize this. So yes, we're doing the very last unit first, and I know that's weird, but it's a standalone unit, and the more practice you get with it, people get better. So, cross off 1. I'm going to go through some P things after, so this is fun. That's fun. That's good. 8 we're saving, so I'll just cross off 8 for now, because 8 is the pathways thing we haven't touched. So it's 9 to 13. Do those. And then we'll talk about using the P permutation button too after.